So welcome to our monthly gathering in March 2023. It's been whizzing away, and you've been hearing me witter away to Martin Lunn, MBE, FRAS, and he's going to wonderfully talk to us all about asteroids, comets, the death of the dinosaurs. So he'll be taking you through your Key Stage 1 primary school training on the dinosaurs. So if you don't know your Diplodocus, you're in real trouble. But mostly, he'll be talking about how we're all going to die. No. Hey, we get near-Earth asteroids all the time. You know, according to the media, oh, we've only just survived that one. But yeah, so perhaps you'll give us a bit more flavour of the craziness that's going on, spinning on around us. Okay, do you work? You do not work. I like it when things don't work. All right, let's
well, they weren't working earlier on, were they?
Screen sharing has stopped. I love IT. You would guess I'd work in IT, would you? Let's try that again. Right, is it going to click this time? It's fine. You're going to change? You're going to change? Oh, that's because I haven't done that. Now is it going to crash? Yay! IT success. Right, we're now up to 102 members. It's creeping up. We were 101, I think, last meeting. So we've got one extra member. That was someone's son has joined up. So they joined for free, but hey, they get a membership card. So they're very excited about that. It was great. We met up on, gosh, when was it? It was the Messier Social. And I said, well, you can join for free. And he went, ah, very excited. Yeah, little chap. Really so he's now a member. Yeah. So we've got our usual crowd of suspects there. So if you see any of them in the street, please feel free to stop them and say hello. This one, I think, is still on doing his community service, because you can see he's wearing a... I'm pointing at Jonathan for people that can't see. Yeah, and Mike still thinks that we've got COVID going. But keep him safe, because he's only just come back from Barbados, so we've got to feel sorry for him. Dear. So what have we actually been up to this month? Well, it's been British Science Week. So that dome, which we thought we were going to do a little bit of dabbling with, we've been doing some monster dabbling with. We visited 6 different schools in British Science Week, and we did some other bits and pieces as well. And we saw, gosh, I saw over 600 kids, and Camilla, I think she saw about 150. So the two of us going around schools, we did 750 kids during British Science Week. So it's kind of cool. And even if it rains, you can do stuff. So we've got the kids writing or trying to, can you guess what they've tried to write? Supernova, yes. So, hey, the teacher for that particular class was sort of saying, oh, they might be a bit tired. I'm not sure we'll get much out of it. I got them spelling supernova in the dark, and they couldn't see what they were actually writing. So that's great. So we're doing lots of that. So even when the weather's inclement, and the telescopes actually got soaked and drenched on that particular night, it was like picking up telescopes and running with them fully laden to get them under cover, because it was running straight down. But also the schools send you the thank you notes as well. So they really do appreciate what's going on. They get thank yous. So Merrick was helping us out on some of the evening sessions we had. So it's great, all the support we can get. And you get the kids just turning around and saying thanks. We got one comment from, actually not British Science Week, before that, which was best lesson ever, which was apparently the best compliment we could get from that particular chap. The teacher was absolutely shocked. But we've been doing loads of that, and it was, we set out to have a busy British Science Week, and we achieved that really well. I discovered that when a school doesn't give you a very good plan, they're going to plonk you in front of a school assembly, and you're going to have to make it up for 45 to 50 minutes in front of 150, 200 kids. So that's a new experience for me. Didn't have a PowerPoint for that. So I talked about the sun. But we also had the Messier Social. So thanks to everyone who came along and took part in that. Not only Messier objects, we did see a few. I actually got 15 ticked off that night. It's not the 70, which is the last time I did it, but the important part was the social side as well. So you can see we had Merrick being char lady there and sorting out the kitchen, which was great. And Sam, newest member, managed to get him up a ladder. I don't think we actually, I'm sure you're not supposed to go onto the top rung of those ladders, but you just about managed to do it without. And I can see everyone's just watching you, just waiting for you to, no one's going to catch, but that's good. So thanks very much. And we had lots of nice little impromptu talks. So nothing sort of too busy or arranged. And so we had Camilla there taking us through this new loan box and things. You were going through a few slides. We had Alex taking us through some of his pictures that he's been taking as well. So there's loads of stuff going on sort of just informally. And we thought the hall was quite big, but as you can see from the photo on the top left, once you put a dome in there and you put a few banners and some cups of tea, we kind of run out of room in that particular. We're going to need a bigger hall. But it was really fun, and thank you for everyone that came along. So we've also been acquiring the new kit. So the loan box that Camilla showed you and took you through the various components has now got some nice stickers on the front. So we've got may contain black holes written on, so that should hopefully excite the kids, and some locks on it just to make sure that things don't go missing during break time. And it's got its first booking. So it's going out on Friday of this week for a loan to a school in Corsham. So we're really keen to see what their feedback is. So again, what we've got in the bottom is a telescope. Then we've got 18 sets of binoculars. Then we've got the Moon, Earth, Sun model, which is called a telarium. Well, that's the little make orbit 2. We've got a gravity well in there, and we've got kits for making planispheres and solar. Oh no, what is it? Yeah, what do we call them? Solar scopes. Yeah. But yeah, they're just for using a CD to make a spectrum, and so you can point them at neon lights or artificial lights or at clouds, not directly the sun, but at clouds, and you can see the spectrum of each of those, the different spectra. So loads of little stuff, and the idea is just to help inspire teachers. All that kit, all the lessons are available online, written by Camilla. So she's really excited about getting the feedback from other teachers because she's done it in isolation, really. And what else we've got on the new kit side is the new go-to telescopes have arrived for our loan scheme, and they're available. We've had one contact, we got 2. So hey, if anyone wants to take part in the loan scheme, we've got one of these that's just not doing anything currently. So hit the website and there's a little booking form on there and you can book them out. And these are very much for sort of beginner. All you need is a smartphone to control them, to find stuff. It does quite a lot of it automatically now. None of that old up, down, left and right kind of stuff that used to scare lots of people off. So hopefully we'll get lots of use. So one's already gone out, and on loan we'll hopefully get the next one out. But we've also got other kit. So we had some C8s donated last year, but they're on old mounts and they are really a nightmare to use compared to modern mounts. So I've started taking those apart and putting them on so they can go onto equatorial, equatorial mounts, so people can start using those for astrophotography. The first one's ready to go apart from some missing bits, which I'm wondering whether to 3D print them up before I put it out, but we'll just have to see. But it's there. This is one of the perks of being part of Bath Astronomical Society, is that we're not part of Bath Astronomers, got to get the name right, is that we do these things. So the loan schemes are there for you to take advantage of. Ian Ridpath's talk has been moved. It was to be on the 26th of April. It will no longer be on the 26th of April because we got, what's the word? Trumped on the day because Dame Jocelyn Bell-Burnell is doing a talk at the Royal High School for Girls on the same night as we had planned, on the 26th. And there's some people that wouldn't forgive me if I allowed the clash to go ahead. So I contacted Ian last night and he's agreed to move the talk back 1 week. So instead of the 26th, our talk will be on the 3rd, which means that people can go on the 26th and talk and listen to Dame Jocelyn Bell-Burnell as well. And I was keen to go as well. So it's another reason why I helped organize it. We've got Dr. Hannah Wakeford coming over from Bristol University talking about exoplanets, and Mary McIntyre is going to talk about women in astronomy. You might want to reconsider that one because I haven't talked to Mary yet, because Dame Jocelyn Burnell's talk is about women in astronomy as well. So come back to me on that one, Prim, if you've been over sort of. You probably can't get enough of that topic, so I'm just going to shut up. But that's what we've got planned. We've got requests out for the new session, which will start in September. So if you do know any Astro speakers you've heard, whether it be online or in person or whatever, or just somebody you know is just amazing, just fire it through and we'll try and get hold of them and see if they would like to talk to us, whether it be in person or online. We'll see what we can do. Okay, so this is the one. If you haven't already and you wanted to go, I'd suggest, because we're helping to promote it, we've got a few followers on social media. You never know, it might sell out. So you have to see. Anyone worried about the £8? The money's actually going into their sort of bursary fundraising. So for some people that can't afford to go there, that they do actually provide these scholarships. So the money is actually going into those, so rather than anything else. So that's probably one of the very good reasons why they managed to get Dame Jocelyn, because we've tried and didn't get a response. I know the Herschel Society has tried a few times and she's not been available or busy. So we'll just have to see. Maybe in person we might be able to persuade her. You never know. You never know. Okay, so we come to the highlight of the evening, which is going to be Martin talking to us. That's not too bad, 13 minutes, about asteroids, comets, and death of dinosaurs. Would you believe that Martin started out working for British Rail? Yeah, but he decided astronomy was a better thing for him, and that was a decision. What was it, nearly 50 years ago, 45 years ago, Martin?
It's going to be about that, late 70s, early 80s. I tell you what, when I took my degree, there were no mobile phones, there were no laptops, no computers, and my dad had to buy me a video recorder so I could record the programs on BBC Two, which used to come out about 11:30 at night.
Excellent. Those are really good ones where people had their little pads on the end of their shoulders and things. Shoulders, elbows. Yeah, those are the natty jackets. Yeah, excellent. And then you went on to sort of like find your feet in astronomy to, was it at the museum? I'm trying to remember now.
It's the Yorkshire Museum.
Yorkshire Museum. You sort of looked after all of their astronomy stuff and the observatory, running all their sessions, all their outreach. Kept you busy for 22 years or so?
Yeah, I was curator of astronomy. I was one of 6 in the country. We're looking at all of your astro for schools. We used to have Earth and Space at the Yorkshire Museum in the 90s, and we used to get 1,000 kids a week over a 6-week period. At the end of that, absolutely wonderful. And looking at your planetarium with an old a star dome planetarium, which actually I kept and used it right through till 2020. And it was a 1991 vintage Stardome. Wow. One of the oldest in the country, I'm guessing.
Wow. Well, ours is only 10 years old and it's definitely showing its age. It's one of those ones where I get covered in glue trying to do all the patches and repairs on it. But it's still running and we'll keep it running as long. It doesn't actually belong to us. It belongs to the University of Bath. But given the outing that we're giving it, or we have done for the last year or so, we're hoping that they just go, oh, you just have it. So we'll just have to see. But hey, the relationship at the moment works really well. And Martin can be found in lots of different places. So if you're one of those people that likes a bit of cruising, beware. Martin could well be on your ship. Okay, so you have your evenings or your speakers on ships, the onboard professionals. Martin is one of those, and he's been doing that, I think, since 2017. So they've not chucked him off the boat. Although I assume during COVID it was a bit quiet.
It was very quiet. Actually, I was up in the Arctic Circle in January. The Northern Lights were ballistic.
Okay, we've got a few envious people in here. Apart from
you can tell that people are making me even more envious because we had an Aurora crown above the ship. It was right above the ship. And where I talking about, you see, if you'd have asked me to talk about the sun and the Northern Lights, I'd be showing them pictures. But you didn't. You asked for this one.
Hey, we got the Northern Lights from Radstock, which is just a village, well, it's actually a small town, just a few miles south of Bath. So hey, if you can get them in Radstock, we don't need to go to the Arctic Circle, do we?
Yeah, absolutely not.
But you can also catch him on radio. You can also catch him. He's got a regular article in the local newspapers as well. Based in was it Earby, Lancashire?
Yeah, it's on the Yorkshire-Lancashire border. The nearest big town, Skipton.
Yeah, and if that doesn't keep him busy enough as well, he either runs or helps run the local astronomical society, the Earby Astronomical Society as well. So a very busy man. Thank you very much for joining us, Martin, tonight. What I'll do is I'll just close down my presentation and I will hand over to you, if that's okay.
That's absolutely fine. I'll just see if I can get this share going again. Right. Well, that was a really splendid introduction. I appreciate it. It's very, very kind of you. Yeah, here we are, coming down. I won't say sunny, the north of England, because it's been raining again up here. So it's been absolutely appalling. One other thing I do that I don't really sort of talk about so much is I do a lot of high latitude novae searching as well. So I take photographs of areas well away from the galactic plane and spend my time just going through photographs and just working out what's what. And I tell you what, you'd be amazed how many errors there are on some of the atlases that people tend to buy these days. It's quite good fun to find these things that are not quite as they should be. Anyway, I digress. Asteroids, Comets, and the Death of the Dinosaurs. It's kind of a funky title, and it's quite an interesting talk as well, and hopefully won't terrorize you and worry you too much, but let's see what happens. Okay, this is home, this is planet Earth, and believe it or not, according to the experts who are in this area, the Earth is in the middle of a 290 million year old spike in asteroid hits. For what that's worth. I'm assuming they're sort of checking up on old craters on the Earth and on the Moon as well. So within this period of time, in the last, say, 290 million years, we've been hit quite a few times, which apparently is a bit above what it was over the last sort of 290 million years. Now, when we talk about a lump of rock, I'm sure you're aware of this, but just in case anyone isn't, a lump of rock in space is a meteoroid. When it's coming through the atmosphere, it's a meteor. When it hits the ground, it becomes a meteorite. So they are the terms that would be used by the people who are studying that particular area of astronomy. And the solar system would have been formed around about 5 billion years ago, with the sun being formed at the center, and then everything coming together to form the planets that we now know today. There's been some really, really interesting things coming out recently about Mercury, which you may have been reading, about the fact that when the gas giants were formed, they kept going in and out and getting close to the sun and coming away and causing all sorts of trouble for the inner solar system. But that's a completely different story. So the solar system forms like this, and of course, if you want to see a star forming area, if you know where Orion is, which I'm sure you do, just below Orion's belt, there's the Orion Nebula. That is a stellar nursery where stars are actually being created as we speak at the moment. And the solar system ends up looking like this, with the sun and the 8 planets we recognize. Of course, poor old Pluto has now dropped off the net and is now classed as a dwarf planet. Now, when we start looking back at the history of the solar system, we have what's referred to as the heavy bombardment period, which goes between about 4.1 and about 3.8 billion years ago. That's when all these lumps of rock are crashing together, forming the particularly the small inner rocky planets as well. And this will carry on right through for the next sort of, I don't know, sort of 3 or so billion years until everything sort of calms itself down. And rather than showing you numerous pictures of 3 billion, 2 billion, 1 billion, we just simply say that for the next few billion years, this carries on. Then we reach a stage where we have, this is the evolution of life on Earth. About 4.6 million years ago, the Earth formed, and then we know there's been 5 big mass extinctions, and you can see them all listed there, and the various geological dates of time which are there. Now, the impact, the mass extinction, which causes all the attention, it wasn't the biggest one, but one that caused all the attention, was around about 65, 66 million years ago, when a lump of rock something in the region of about anywhere from, well, it depends which reference you go to, 6 to 10 miles across. And it bumped into the Earth at about 38,000 miles per hour. And it left a belting great hole in the Yucatan, what is the Yucatan Peninsula now. The experts, keep using the word experts, reckon it had about as much energy as 100 million atomic bombs, which is pretty big. And there are our friends, the dinosaurs there, and certainly any kids watching will know and recognize sort of Tyrannosaurus and probably a Stegosaurus there. Oh, I should just mention, as a little diversion there, one of the jobs I had to do at the Yorkshire Museum was help our friends in the natural history department. And at one point, I was assembling and disassembling 14 tons of dinosaur bones. And I do assure you, after a while, that becomes a little bit, well, 14 tons, that's a lot of bones. And also, again, of academic interest, but interest nonetheless, what we call the Stegosaurus, the Chinese call it a Huyangosaurus. So anyway, a little bit extra information just thrown in there in case anyone wants it. But get back to this meteor, which struck 66 million years ago here on the, in the Gulf of Mexico off the Yucatan Peninsula. And it made this belting great hole. And the closest modern day village to it is Chicxulub. And that's why we call it the Chicxulub crater. And of course, it was discovered when people were looking for oil. They were drilling down through the ground and they discovered what appeared to be evidence of a meteorite crater. Now, when they was trying to study evidence for this, they were looking for elements that are pretty rare on Earth, but pretty common in meteors. And one of those being iridium. And when they started looking down, they suddenly started finding that they had massive amounts of iridium, far more iridium than you ever would expect from a meteor. And they couldn't work out what was going on. This was back in the late 70s, early 80s. And what they then decided, they just couldn't work out what was going on. And then someone started, who's actually examining the bits of rock? Who's looking at it? The researchers here. And most of them were women. And look, most of them were not wearing gloves, because they didn't tend to wear gloves, which you see people today wearing. And they looked. Most of them were married. Most of them had their wedding rings. And what they realized was, as the researchers, say particularly women, were examining these bits of rock, micro little bits of iridium was just dropping off the gold rings and going and contaminating the lumps of rock. And suddenly they were getting, the amount of iridium was off the scale. So what the women had to do was to take their wedding rings off and then carry on the research, and then they got the correct amount of iridium that they was expecting. So it's amazing when you do research, sometimes you bump into problems and issues that you're not quite expecting. And that was an interesting one there. When the meteor struck, it triggered global firestorms, which hurled enormous amounts of material around the globe. And it's reckoned that with the energy, with the rocks, with the heat, with the blocking out of the sun and the poison gases that were everywhere, they reckon most dinosaurs were dead, certainly probably within a month. And that was it. It was just that quick. And again, you have these sort of pictures like this. They certainly would have survived for a short period of time because there'd been loads of dead things for them to sort of scavenge off. But then that would be it. And we'd have effectively what astronomers refer to as a nuclear winter, with the dust and the ash just blocking out all light from the sun, and the temperature, everything, it just cannot even begin to imagine what it must have been like. But we know, of course, some critters did survive. In particular, many freshwater critters survived. These are lots of little animals which are able to adapt to changes much quicker than the dinosaurs were able to do. And of course, they would survive, and then they would repopulate the Earth. And then, of course, you go from the time of the dinosaurs to the time of the mammals. And these little critters like this, it's a little water vole. In fact, my wife does a lot of volunteering work for the National Trust at a place called Malham up in North Yorkshire. And 3 or 4 years ago, they were putting loads of little fellows back into Malham Tarn to try and repopulate it. The trouble is, these little critters are just about predated by everything. So their chances of survival aren't good, but they're hoping that some of them will get through. If you want to see a dinosaur today, you've got to go to a museum, really. And, you look at these things here. Or if you look into your garden, you may see one of these. These are modern day dinosaurs. The birds, we have to say, are actually descended from the dinosaurs of those 65 million years ago. Okay, that's the dinosaurs. And that's the big impact there. When we look up into the sky, look up at the night stars, it looks very, very serene, very, very calm, very little going on there. We know there are 5 naked eye planets. We have Mercury, Venus, Mars, Jupiter, and Saturn. And if you've been following the news over the last couple of days, the news reports being told you can see all 5 planets by just popping into your garden. Well, if certainly where I am, Jupiter and Mercury are, well, if you can see them, you're doing really well. Uranus, you kind of like need a telescope if you're going to look at that. But anyway, that's the press people get hold of these stories and it just sort of gets magnified a bit. So the people living thousands of years ago knew there were 5 of these stars that moved across the sky. They knew that the stars stayed in one place, apart from these 5. And the Greeks called them wandering stars. And the word they used to describe these wandering stars was the word planet. That's where it comes from. And of course, they assumed they had to be gods. Now, up until 1781, actually, we're going to come into your neck of the woods in a minute. Up until 1781, there were 5 planets, the sun and the moon, that made 7. And 7 was always regarded as a bit of a magical number. But then in 1781, William Herschel discovered the planet that we now call Uranus. And it was an absolute sensation. Nobody was expecting it. And it really made astronomy very, very vibrant again. And in fact, there'll be loads of things happening astronomically in the back end of the 18th century. Lots of things would have been bouncing off Herschel's discovery. I'm sure sales of telescopes went through the roof at the time. Now, with the discovery of Uranus, some of the people who like playing around with numbers and statistics and maths start doing all sorts of interesting little things. Now, we know the distance from the sun to the Earth is 93 million miles or 149 million kilometers, or 1 astronomical unit. And you're probably aware of something called Bode's law. And Bode's law says this: if you take these numbers here, if you add 4, then divide by 10, you get the astronomical distance. And of course, when Uranus was discovered, it pretty well fitted in. So everyone thought, wait, hang on. We've got all of these things. There's nothing here. There is nothing here. There's no planet there. So there must be a planet there we just haven't found. And then, of course, they start looking, and you have all sorts of astronomers start exploring the area of sky where what we now refer to as the asteroid belt is. And sure enough, they discovered a series of asteroids. The first one being Ceres in 1801. And since then, of course, literally millions and millions of asteroids have been discovered between the planets Mars and the planet Jupiter. And here is the asteroid belt. Now, the asteroids themselves, as long as they stay where they are, they don't really cause us too many problems. It's if any of them get nudged and come in our direction, that's when they start presenting issues and problems for us. And here are the 4 largest asteroids. Now, back in the 1940s, the Dutch-American astronomer Gerard Kuiper predicted that there will be a second asteroid belt out beyond the orbit of Neptune. And of course, he was quite right, and we call that today the Kuiper belt. So we have the inner asteroid belt between Mars and Jupiter, and the outer asteroid belt beyond Neptune, which was discovered by or predicted by Gerard Kuiper. And Pluto, of course, is inside that Kuiper belt, and there are loads of other objects in there as well. And I'm sure there'll be more dwarf planets to be discovered in the future. Now, the first object to be discovered in the asteroid belt was this one here, 1992 QB1. And it was discovered by Dave Jewett and Jane Liu. And they were using old-fashioned photographic techniques at this day. They wanted to call it Smiley, because some people in the control room actually reading the book Smiley's People. But they couldn't, because there was already an asteroid called Smiley. And it seems rather strange that this little dot here, the first object found in the Kuiper belt, still has its name, 1992 QB1. Well, there you are. So you've got all these little lumps of rock. You've got these trans-Neptunian objects. You've got all these inner asteroid belt, outer asteroid, all happily going around the sun, sometimes bumping into each other, sometimes sending bits of rock in towards the inner part of the solar system. And all of these, of course, are all potentially dangerous to us. As long as they stay where they are, doesn't bother us, but they can. Now, we just need to have a quick look at comets. get these wonderful pictures of these old-fashioned drawings of what people thought comets looked like. There's Halley's Comet, and there's Comet Hale-Bopp. Hale-Bopp. It terrifies me when I think Hale-Bopp was what, sort of 1997, and you just think, crikey, that's like 25, 26 years ago, and you think, my word, it was that long ago. But it was. And of course, comets, depending on what reference you go to, are either dirty snowballs or dirty ice balls. Just depends on which sort of reference you seem to go to. And of course, these comets travel around the solar system. And again, as long as they travel in their paths and don't come too close to us, well, it's not really a problem. The problem only occurs if they sort of nudge towards us. Remember, planet Earth going around the sun takes a year to go around the Earth. And if something's coming towards us, if you're in a car and something's in the road in front of you, you can just turn the steering wheel. You can't do that with the Earth. If something's there, it's just going to bump into it, which is not good. And you may remember Comet 67P, which was visited by the Rosetta mission back in 2014. And a little probe called Philae sort of landed on it, and it sort of bounced around a couple of times and then sent back loads of information. What's interesting here, though, is that with Comet 67P, with the close-in observation, they suddenly noticed that there was bits of comet material. Well, we know a comet leaves a trail of dust behind it, but they were finding bigger bigger chunks of rock just falling off, following the comet in its path around the sun. And our friends in the Czech Republic, they're some of the leading researchers into meteor streams. And they were rather perturbed about 3 years ago when they discovered in the Taurid meteor shower, they were coming across lumps of rock between 200 to 500 meters across. Now, that's okay until you stop and think about it, because the Earth cuts across the Taurid stream. We have the Taurid meteors in early November. So that's potentially worrying. But having now seen what happened with the Comet 67P, it can't be too surprising that the comets don't just leave trails of dust behind it, they leave trails of dust and perhaps pretty big chunks of rock as well. And of course, the comets, we have the Oort cloud, we have comets all around the solar system, and it was Jan Oort who came up with this idea. And again, as long as the comets stay there, there isn't a problem. It's only if some of them bump into each other that they might be pushed in towards us. And now here we are, there's the Earth. There's the Earth going around the sun, and there's the path of a comet. And again, if the Earth passes through that stream, we see loads and loads of meteors, or shooting stars, as people like to call them. But there may well be some bigger chunks of rock flying around there. Some of those may have bumped into us in the past, and some may well do so in the future. Now, here's a picture you've probably seen quite a few times online, the NEOs, or the near Earth objects. And here you've got the sun in the middle, you've got the orbit of Mercury, Venus, the Earth, and Mars. All the green dots, it's the typical green, orange, and red. The green dots are the asteroid belts. As long as they stay where they are, don't cause us problems. The orange belts, the orange dots, well, they come close to the Earth, but don't cut across our path. The red dots do. And of course, they're the ones that are potentially the ones that we need to be careful of. They're the ones that can potentially cause us some issues and some problems. Now, what I want to do now is take you on a little track and just look at some. We've done the dinosaurs, but there's been other meteors that have come in, some in more relatively recent times, some not quite so recent, but they're interesting in their own right. And I want to start this part of the story by going back 3.3 million years, not billion years, just 3.3 million years. Because an object about a kilometer across hit what is modern day, or hit the sea, which is just off modern day Argentina. So there's a clock going off in the background. I do apologize. We've had to move it because where I normally work, they're doing things like that, so I have to move into a different room to do this. This object was about a kilometer across, and it pelted this area here, or what is modern day Argentina. And interestingly enough, at that time, this is Panama, or where the Panama Canal is, but about 3 million years ago, a land bridge formed there. And what's the people who study animals and how various species do get made extinct was that 3 million years ago, when this land bridge is formed, this meteor hits, and it actually caused a mini mass extinction in this part of South America. And quite a few critters who lived in the northern part of America ambled across this bridge and then colonized areas where there once was animals, but they'd been removed. So it just gives an example of just how important, how dangerous these lumps of rock can be. So it was about 1 kilometer across as far as they can work out. And it landed, say, somewhere in the South Atlantic Ocean. Okay, let's now, that's a million years ago. Let's come forward now just to a few thousand years ago. Let's have a look at the Younger Dryas event. Bill, the last ice age is going to finish, and then the temperature on the Earth is going to rapidly increase, and then it's going to cool off pretty quickly. And something rather interesting happens because there's something called, this is the Dryas octopetala plant, and it's a plant you tend to find in the tundra, northern Siberia. And yet it was discovered all over the Mediterranean, Europe, North America and Central America as well, which gives you an indication that something has happened that has caused the temperature on the Earth to drop very, very quickly and very, very sharply as well. And no one's quite sure whether volcanoes could have been involved, but recently scientists have discovered what appears to be an impact crater in the northern part of Greenland. Now, there's quite a wide spread of when it actually hit. No one's quite sure, but there are some suspicions that this was the culprit for forming this particular event, the Younger Dryas event, of about 12,000, 11,500 years ago. So that had that impact, and of course it had an impact on us as well as our species, because our species will turn from being hunter-gatherers to farmers at around about this sort of time. So these sort of events do have pretty big implications on us as a species. You know, our friends here disappeared, and say we went from being hunter-gatherers to farmers. Particularly, obviously, this is where the sort of the cradle of life seems to be, this sort of area here. Now, what may seem to be a little bit bizarre is looking for stories of science in the Bible. That really doesn't make much sense until you start looking. And then you do find some very interesting things. Now, there's loads of research that goes on between astronomers, geologists, biblical studies, historians. They can come up with some pretty interesting stories. For example, you will know the story of the Great Flood. But around about 3,700 BCE, BCE is before the Common Era, an object, a meteor, impacted what is modern day Austria. Yes, it is somewhere in the region of around about maybe 100 meters across. Difficult to say, but that's sort of order, maybe a bit bigger. And when you talk to the folks who study meteors as they come into the atmosphere, so the dynamics of the air being squeezed and pushed as the pressure between the ground and the front of the meteor is increased, the experts suggest that lumps would fall off in this particular area here, close to the eastern Mediterranean, into the eastern Mediterranean. Now, if that's the case, you're going to have tsunamis being formed. Now, we're going back 5,500 years, so people are not going to travel around very much. Suddenly, you've now got a story for a great flood. Now, for sure, there'll be lots of people who would have perhaps had boats, jumped in boats, and perhaps rescued people, but the story would get inflated, changed around, chopped around, the myths would build up, and suddenly one guy called Noah builds a boat called the Ark to rescue all the animals and all the people. So it could well be that that story from the Bible is actually based on an astronomical event. So you might say, okay, well, you plucked a story out there. I'll give you another story from the Bible. Again, this is researchers who have done this. We know the story of Sodom and Gomorrah, these two towns, all sorts of badness going on there. And we also, the Bible's going to tell us that God's going to throw thunderbolts down and totally destroy these two areas. Well, archaeologists we're doing lots of research work in this area here where they believe the Sodom and Gomorrah were based. And they were coming across bits of pottery with sand that had been fused into glass at an incredibly high temperature in a brief moment of time. And also, they discovered there were pressure forces on various quartz, various bits of rock in the ground. And again, the geologists now come into this, and they were saying that whatever squeezed these rocks had as much pressure as about 725,000 pounds per square inch. Now, to give us something, if you took your thumb, put it on the ground, let a Challenger tank run over it, it's about that sort of level. The suspicion seems to be we had an airburst. A meteor, a comet came in and airbursted over this particular area, and then it did its damage. The archaeologists then tell us that for something in the region of about 200 square miles around where Sodom and Gomorrah were based, all towns were destroyed, and no one lived there for about 500 years. So interesting, you know, you can look into these strange places for references and you get these strange sorts of stories coming back. But again, the story of the destruction of Sodom and Gomorrah seems to have an astronomical connection. Now, sometimes we can have jewelry being used from an asteroid impact. Now, the Hopewell meteorite, which landed sometime between 252 and 283 CE, CE is the Common Era. This is in America, and it's in the Ohio Valley in America, and archaeologists there have found loads and loads of evidence of little bits of meteorite, and more importantly, meteorite turned into jewelry, which is kind of interesting. They're not the only ones, but it's just interesting that loads of researchers now, and this is really all current research as well, they're finding these various bits of ironwork and jewelry, which is made from bits of a meteorite. You can imagine just how significant that would be. Now, I've taken you on this journey. We've gone back 3.3 million years, and we've now sort of coming closer to the modern time. And from about 500 onwards in history in Europe, monasteries become really, really important because they become the centers of learning. They become the place where you have the great libraries. So it's interesting that we can get a little bit of information from a fellow who I've taken a real shine to, because let me show you who he is. This fellow is called Saint Gildas. Now, he's known to have lived, he's a monk. He lived between 500 and 570. In ecclesiastical ways, he's really looked at as very, very important because he gives loads of information about what England was like in the 500s. In other areas, he's branded as being as nutty as a fruitcake because he's talking about God throwing down this vengeance and this destruction and all this, getting rid of all of the badness on the earth. Now, he's a very clever, he's a monk, he's intellectual, he's clever, he's not a scientist. What he has witnessed, he can't explain. He hasn't had the words. He hasn't got the science words. It's a bit like you folk in Bath. If, for example, a fireball came and airbursted above Bath and you were speaking to people and you spoke to a dozen people, they would tell you it was what color it was: red, blue, green, yellow. Which way was it going? That way, that way, that way, that way. How big was it? This big, that big. Because then they're not scientists. They haven't got the language to use. What he's describing is an airburst event. Something hit the earth in 536. And he witnesses it and he writes down, and he thinks it's God throwing something down. We then get a better written reference from a fellow called Michael the Syrian, who's another monk. And he tells us in 536, but you can read what it says. The sun was dark, and this darkness lasted for 18 months. The light was very feeble, fruits didn't ripen, the wine tasted like sour grapes. Now, at this point, you've got people doing research into ecclesiastical studies. You've now some colleagues of mine who do research into comets got involved in this. And then you get the people who study trees, the dendrochronologists getting involved in this as well. And they start taking tree ring measurements. And they find that from 536 to 548, tree ring growth across Europe and part of North America stop. Whatever's happened has actually blanketed out the light from the sun. And the current guess is it's an airburst again. Now, we have little information about how many people were killed? Some people almost certainly were, but there is very little information other than the fact we know this event has happened. And we maybe can liken it a little bit to the Tunguska event of 1908, when an object about 50 meters across airburst above the Tunguska River. And we all know the story behind that. Now, I'm not a train expert, but I used to work on the rail. We didn't used to work on these sort of trains. And this, according to the internet, this is a Trans-Siberian Express train from that particular period. And on June the 30th, 1908, one of these was 400 miles from the impact site when it got hit by the shockwave and the carriages were rattling around. And the engineer stopped the train because he thought the train had become derailed. It had just a shockwave going over it. And again, you'll have seen pictures like this of Tunguska when the scientists got there and they found all these trees just blown over. About 80 million trees were destroyed over a sort of several hundred square mile area of land. Now, what's interesting is in the 1600s, in a place called the Isle of Axholme, which is part of Lincolnshire and part of South Yorkshire, the fenland was being drained by people so you can use it for farming. So get rid of all the water there. They dug down the yard, and what they found were rows and rows of trees, all blown down, exactly the same way as the trees in Tunguska. More evidence to back up what old Gildas has told us, that something happened. He puts it down to God. We know it was either a comet or an asteroid coming in and air bursting and causing that destruction. But it's interesting nonetheless. If, for example, you wanted to take your 50-meter lump of rock and drop it in the ground, well, you get something like the Meteor Crater in Arizona or Wolf Creek in Australia. You get that sort of size. It's better for it to land on land rather than the water, because if it lands in the sea, it produces a big sort of super tsunami, which is not good. Now, just briefly, some other very, very sort of famous meteors just to mention, or meteorites. There's the Middlesbrough meteorite, which I was lucky enough to work on. That's at the Yorkshire Museum, one of the most important meteorites on Earth, and that fell in 1881. There's the Peekskill meteorite, which hit this young lady's car in 1992 in America. Actually went through the car and through her driveway into the ground. And this one here is a young lad who back in 2009 was walking to school in Germany, and he got hit by a pin or a pea-sized meteor, which sort of whizzed past his hand and just caught his hand before he hit the ground. So he had a little tiny scar in his hand, which is now three sort of fairly famous, or very, very famous stories from more modern times. And of course, but the other year, was it 2 years ago, we had the Winchcombe meteorite, which landed down in your part of the world. I mean, I shouldn't talk to you. You know more about the Winchcombe meteorite than I will. That's one that landed on that person's driveway. And what's really nice to see the expert using gloves to hold it, because obviously we have all sorts of chemicals in our fingers that can cause problems. Those. Okay, now I'm taking you to the big end of the meteors. It's only right and proper to just take you back down to the other end, to the micrometeorites. Now, that actually isn't a micrometeorite. That's actually too big to be a micrometeorite. These are objects on the nanoscale. So if you imagine your 30-centimeter ruler, forget the centimeters, go into the millimeters and go 0.0000001 of a millimeter, and you're on the nanoscale. And when you go outside, you're actually hit by about 7 of these every second. They just sort of slowly sort of cascade down through the atmosphere of the Earth. Now, you can actually catch them from your garden. Great fun doing this. All you need is an ice cream container. This one isn't empty, but it needs to be empty, really. Ice cream container, a coffee filter, and a jar. Now, you need a microscope. You don't need a powerful microscope, but a toy microscope isn't going to be good. It wants the sort of thing you may have at primary school, that sort of microscope. So what you do is you take your little ice cream container, put it outside in the garden for, I don't know, 2 or 3 days, with maybe a couple of inches of water inside it, and just leave it there. Make sure cats can't get out of it, because they drink all the water otherwise. And after a couple of 3 days, bring the container in, pour the water through the coffee filter, which is on top of the jar. The water goes into the jar. Now, you don't need that. So here you've got the coffee filter with a load of sort of material inside. It can look quite black and horrible sometimes. Any leaves and twigs, just sort of get rid of those. You then put that material onto a microscope slide, and when you stick it onto the microscope, you'll see all sorts of things, including little bits of bone, little bits of seed, little bits of wood also, and some little spherical objects, which will be magnetic. They are micrometeorites. And it's always good fun to try and catch micrometeorites. And one of the things we used to do a long last century, it'd be now, if you're working with sixth form students doing physics, get a little plastic sort of swimming pool, put on top of a physics block roof in the days when health and safety wasn't so strict as it is today, and leave the water, leave it, I don't know, maybe 4 or 5 inches of water in it for, I don't know, 3 or 4 days, and then get a powerful magnet, skim the surface of the little paddling pool, and then check and see how many micrometeorites you got. If you know the surface area of your swimming pool, work out the surface area of the Earth, and you can work out how many micrometeorites are coming at any day, week, month, or year. So sort of fun thing to do. That's what we used to do. Probably not allowed to these days because of health and safety. But anyway, that's one of the things we used to do back in the old days. Now, the moon. Now, we talk about objects hitting the Earth. Now, of course, the Earth has an atmosphere, so the Earth can actually bounce some of them off. But the moon doesn't have an atmosphere, which means we can look at the moon and get some idea of how often the moon's getting hit, or has been hit, and is getting hit. And there's something called the Lunar Reconnaissance Orbiter, a NASA probe that's happily orbiting the moon. And interesting enough, between 2009 and 2016, it took 14,000 pairs of photographs over just 6% of the moon. And what they discovered was over 200 new craters between 30 to 150 feet had appeared on the moon. In that period of time, between, as I say, between 2009 and 2016. Now, the NASA people come out and say that actually was 33% more than what they'd predicted. Now, as they didn't know how many were actually hitting the moon anyway, to sort of predict how it's more than what you thought it was interesting. And also we have sometimes people actually photographing the moon. They've actually captured impacts on the moon. I think there was one in 2013, maybe, where an astronomer had his telescope pointed at the moon and actually caught a little brightening on the moon as something actually thumped into it. And this is something, of course, that future moon bases are gonna have to be aware of. Now, I know. Was it Shaun the Sheep went to the moon last year? And I know they're planning on sending people to the moon in 2025 with the intention of setting up a moon base. But my word, you have lumps of rock traveling along at 30,000 miles per hour, and you know, they can be maybe a meter wide. That'll punch a pretty big hole in the roof of your moon base. It'll cause you a few problems. And something I think they're going to have to be thinking about for the future. This is a nice little interesting picture because it shows us, talk about the moon, this is the Earth between 1988 and 2019. These are reported fireballs. The big red one there is Chelyabinsk from 2013. We'll have a look at a picture of that in just a moment. But you can see the Earth does get hit by quite a large number of objects, anywhere from sort of 1 to sort of 15 meters across. Chelyabinsk was about 15 meters across. The other ones are all much smaller. Most of them just burn up in the atmosphere. They do produce rather spectacular fireballs in the sky. And of course, most of them will actually land in the sea, or they always end up landing in some place, you know, well away from any civilization. So they can be quite hard to capture, so as to speak. It's worthwhile bearing in mind it's not just the moon and the Earth that gets hit. Jupiter gets stumped as well. And who can remember back to 1994, depends on your age, I suppose, comet Shoemaker-Levy 9, a small comet. It went a bit too close to Jupiter and it got broke up by the gravitational field of Jupiter into a string of pearls, about 20 lumps of rock. And they all, one after the other, just smashed into Jupiter. As Jupiter's rotating, you just see these holes appearing around it. And what was quite fascinating, just after this, some geologists and some astronomers were working together. Actually, it might have been geophysicists. And I think it might be Nigeria in Central Africa. There's a whole series of craters in a straight line, and no one could quite work out why they were there. And one of the ideas had been that maybe an object had come close to the Earth and broken up, and bits were and it was difficult to prove. Now they suddenly had a bit of evidence to say that is almost certainly what's caused those craters in the central part of Africa. So that was the useful exercise for them. That was in 1994. Another one was in 2009. And this was discovered by an amateur astronomer, a backyard astronomer, an Aussie. And he actually photographed this spot here, and other people then confirmed it. And you see, the thing is, by 2009 and through to today, people like ourselves, we have equipment, telescopes, computer-controlled telescopes, cameras that are as good as astronomers' telescopes were maybe, I don't know, sort of 30 odd professionals, sort of 30 or 40 years ago. So what astronomers can do in their backyards is to photograph these planets or photograph other objects in the sky and study them. And and this is going a little bit off track again, but I bet you if there is a planet beyond Pluto waiting to be discovered, I bet it'll be a backyard astronomer who will actually pick it up at some point in the future. Let's just wait and see on that. And again, still same with Jupiter. We've got another one here. This is the one on the in 2019. You can see it's been imaged there in red, green, and blue, and again here in red light as well. So really nice images of it there. And this is the Chelyabinsk meteorite or meteor of 2013, and that's the one when it came over the Earth. What was it? I reckon it's about 15 meters across. But the sonic booms coming down, they caused many windows to shatter, and about 1,000 people on the ground actually got hurt by flying glass. And shortly after that, in 2018, another object came in. This one they reckon was bigger, about 30 feet across, much bigger than the Chelyabinsk. But this actually came in over the Bering Sea, and obviously it didn't sort of impede anything or anyone there, so that was all okay. But it does just that's the area of sea between Russia and Alaska, and it does sort of give this indication of just how dangerous it is with these lumps of rock coming in. Now we're now sort of coming much closer up to the modern day, and this is one which caused lots of fun back in 2017, because this was an asteroid. It was about 150 meters across, and what was interesting was it missed the Earth by about 75,000 miles. Now bear in mind the Earth is blasting around at about 166,000 miles per hour. But what was interesting with this one was it wasn't seen coming in, it was seen going out. So the astronomers said, hey, what was that? And so it's all very well to have cameras, telescopes looking for these objects, but they've got to find them. If you can't find them, then we're in all sorts of trouble. And that was an indication there. Now, of course, at the moment, I'm talking about lumps of rock, I'm talking about asteroids, I'm talking about comets, but let's make sure we get good old humans. Let's get us into the frame, shall we? Because man-made satellites, well, they can come down as well. Skylab, Mir, the Chinese Long March. Now, Skylab, back in 79 it came down. It was in the early 80s it came down. And the Americans had used it as a space station. And the idea was when it came down, they had just enough fuel on board to tip it into the Indian Ocean. The only trouble was they missed. How you can miss the Indian Ocean, I don't know, but the Americans did. They actually hit Australia. And it did cause an awful lot of trouble because I was worried about little bits of radioactive contamination. The Russians, on the other hand, with their Mir satellite, they did divert into the Indian Ocean. So that went down very well. The Chinese, on the other hand, have a very blasé approach to launching things into space. They use their Long March rockets, and the rockets go up and they deliver their cargo, and the second stage is and they just drop away and they hit wherever they're going to hit. Most of them do seem to come down in the Indian Ocean, but they've come down pretty close to the Maldives, and they've, you get sort of a 22-ton piece of material coming in. Sure, a lot of it will burn up, but some won't. Now, as interesting as they are, we do have one really serious issue orbiting the Earth. This thing here, Cosmos 482. It was launched in 1972. It was going to be Venera 9. Now, when the Russians launched their spacecraft, they have a Cosmos number, until they escape the Earth's orbit, and then they get their designated number. So Cosmos 482, once it left Earth orbit, would become Venera 9. Well, it didn't make it. And it's stuck in orbit around the Earth. That's bad enough. The problem is, it is going to come down within the next couple of years. They reckon it's going to be down for sure by 2025. The drag of the Earth is pulling it down. That's bad enough. The problem is, this is a probe designed for Venus. Now, by 1972, astronomers knew that Venus was the hottest planet in the solar system. It rained acid. The atmospheric pressure was enormous. They knew all of this. They knew that spacecraft wouldn't last very long on the surface, so they were built like mini tanks. This is built like a mini tank. It's built to survive the Venusian atmosphere, which means, of course, coming back into the Earth's atmosphere is going to be a doddle for it. So very little of it's actually going to burn up. So you're going to have something in the region of about 1,000 pounds of spacecraft dive bombing the Earth. And just to round that story off, there's no control over it. The Russians have, it's literally, it's just going to be wherever it lands is wherever it lands. And I know that the people who monitor these satellites are watching this one like a hawk, because when it does come down, you will hear about the people be keeping on it, that last orbit or so before it actually enters the Earth's atmosphere. So, okay, when's the next one gonna strike? Wow, that's never easy to say, is it? We had another one, this was on 2019, this missed us by, what, 43,000 miles. This again, was it 50 to 100 meters across? That's big enough. That's going to cause a lot of trouble. 50 meters across, they're city busters. Now, they're the ones that are just going to take out a city if they land in the wrong place. And you would have heard on the news the other day, this object whizzed past us. I just found this rather amusing little graphic. This was last week, I think it was. It near missed us by, what does it say, 100,000 miles. And again, that's big enough to do serious damage. What I found interesting about this was, it said that, actually, I've had people say to me, did I see it? And well, no, it's about magnitude 19, I think is what it was. What I found interesting is that this is predicted to return in 2026. Now, assuming its orbit doesn't get too disrupted, that kind of implies it has an orbital period of about 3 years around the Earth, in which case it may well have buzzed us who knows how many times in the past, and no one even saw it. So that's one, again, they'll be keeping an eye on. But how do we stop an asteroid? Well, NASA may come to the rescue, because you remember last year we had the DART mission, the double asteroid redirection test, where they flew a spacecraft directly into an asteroid called Dimorphos, which was a little asteroid which orbited one called Didymos. And they just deflected it, of course, slightly, but enough. So everyone's really pleased about that. So we know we've got that little bit of basic old-fashioned technology, being able to nudge something out of the way. Of course, you've got to be able to find it first. You've got to be able to see it to be able to fire the rocket at it to divert it. So hopefully they'll be able to do that. And lastly, well, what could come in the future? Well, how about this one here? Friday, the 13th of April in 2029, an object called Apophis. Now, Apophis is the Egyptian goddess of terror, which is always a good name to have for an asteroid. That's actually going to miss us by about 19,000 miles. It's around about 300 meters across. Now, 19,000 miles, that's within the geostationary area for satellites. So it's going to come pretty darn close. We have to make sure they haven't got the little decimal point in the wrong place where they're working out the orbital period of this particular asteroid. So that's the next one that we know of is going to come close to us. There may well be more between now and 2029. I suspect there will be, and I suspect we'll hear about them on the press as well. So there you have it. That's a little journey looking at asteroids, comets, and the death of the dinosaurs. As they used to sound some TV programs, sleep well tonight, sleep safe. You know, the chance of getting hit by a meteor are quite small. And I'll leave it there. I'll stop the show. I'll answer any questions that you might have. Thank you very much.
Thank you, Martin.
Oh, you're very kind. Thank you.
What questions has the audience got for Martin? There must be some.
Hi, I have a question, Richard Bottle.
Go for it,
Yes.
Rich.
There is a rock in the wall of the Kaaba, which is the temple in the middle of the Grand Mosque of Mecca.
Right.
That's often been described as a meteorite. Do you know anything about that? Have you got anything to say about that?
No, it may well be. There are lots. I mean, they found a dagger in the tomb of Tutankhamun that's made from meteorite material. So it's quite possible there is a piece of meteorite material there. Whether anyone's been allowed to do any analysis of it, I don't know, because that would be the surefire way of doing it. We used to get at the Yorkshire Museum, we had an identification service, and we had people bringing in lumps of rock that they thought were meteors. And invariably, they'd bring in a piece of old slag from a foundry. And you had to then, rather than say, it's a piece of old slag, you had to sort of really sort of, well, yes, it's a piece of slag. It's come from a factory. But that factory was down the road and they were producing this and they were making it really. So, in the past, there have been loads of meteors that have been seen to hit the ground. And we saw with the Hopewell meteorite in America, they're using it for jewelry. So if one has been seen to come down in the Middle East, someone may well have taken a piece and just stuck it in the wall. I mean, who knows?
Yeah. The other quick point is I'm aware that on occasions meteorites are found on Earth and they're identified as being from the moon or
Yes.
from Mars or whatever.
Yes.
I find that quite intriguing that people are able, to make that identification. Or I think some of them are identified as coming from particular asteroids.
Yeah, well, Byron's helping me out in the background. He's giving me some information. You may hear him in the background. Now, bear in mind, if a lump of rock hits the moon or hits Mars, but the gravitational pull on both those objects is quite less than the Earth. So anything thrown into space will enter orbit around the sun. And if it comes close enough to the Earth, can actually hit the Earth. We know what the moon looks like. We know we've got moon rock, so we can analyze that. Martian rock, we got a good idea what Mars is made of, so it's possible to get an idea if we find a bit of rock on the Earth that's a meteorite and it's linked into Mars. The experts, the astrogeologists are pretty good at being able to say, yes, that is a piece of Martian rock. Yes, that is a piece of lunar rock. Now, whether there's any bits of mercury on the Earth, I don't know. That I really don't know. You need to speak to the meteorite people themselves about that.
Okay, thanks.
Okay.
Thanks, for that, Richard. What other questions have we got? We've got one from Prim. Hopefully that works.
Thanks. I just wanted to ask, could you give a bit more information on the airbursts and what's actually going on? So I can imagine this sort of meteor coming in. Is it exploding before it hits the ground? What exactly is happening with the airbursts?
Right. The meteors are either very, very tightly held together or they're just loose bits and bobs. Remember Comet 67P? They can see it's just little bits and bobs held together just weakly by gravity. So when this object enters the Earth's atmosphere, it's coming in 30, 40,000 miles per hour. The air in front of it is going to start getting squeezed. The air pressure will change, the temperature will change, the wind direction changes, and that's being squeezed and squeezed. So the pressure being applied to the front of that comet or front of that object is enormous. Now, if it's only loosely held together, it's going to, if it's made, particularly if it's made of iron, it's unlikely to do that. It does come down as one lump. But that's what invariably happens, is the pressure that builds up between the ground and the front of that meteor coming in. And it's only going to take, it won't take 5 seconds for that to go from the space to hitting the ground. So it's all going to happen in a very, very small number of seconds. The pressure builds up and then it just blows up. But astronomers tend to call them air bursts.
Brilliant. Thanks, Martin. Can I just ask a quick one if nobody else is asking one? How easy is it to identify if you have got a genuine meteorite, and do you have to go to a mass spectrometer, or what do you have to use? Is there
in meteors, pretty much everything you get on Earth, you find in a meteor in different proportions. It's a bit like making two different cakes. You have the same sort of ingredients, but if you alter the proportions, you get a different end result. Things like iridium, yttrium are very, very common, and geologists will then look for little bits of evidence to suggest there is something there which isn't really terrestrial. And of course, that's how they used to identify them before the modern day techniques that are used today. And in fact, if you are a geologist and you're about to pass your finals, you'll be given loads of bits of rock to identify what parts of the world they're from. If you have a pretty sneaky geologist professor, they may well put a little bit of meteorite material in just to see whether you can identify the fact that that doesn't appear to be terrestrial in any way. So yeah, they have their own ways of actually just checking for those different elements inside those bits of rock, which will identify them as being meteorites as opposed to being terrestrial rock.
Thank you.
Stephen?
Going back to the airbursts.
Yeah.
The meteorites, sorry, the meteors which cause those, they could be from either comets or from asteroids. Is that correct?
Oh yes, it's really, you're going into an absolute grey area now, because what's a comet, what's an asteroid? Because we know that there are lots of asteroids traveling around the solar system which look like they're dead comets, because a comet is basically a dirty snowball. Or an icy dirt ball, whichever one you want to look at. And as it goes close to the sun, gas and ice is burned off. Eventually, you just end up with a lump of rock. So yeah, it's an area. Is it a comet? Is it an asteroid? I think it becomes quite difficult to work out what exactly it is. So when people talk about a comet air bursting, it could well be a very loosely held together asteroid air bursting. And you really would need to speak to an absolute expert in that area to get a definite definition. And I think even then you might struggle a little bit.
I wonder, Martin, in the Herschel Museum here, they had a visitor a few years ago who noticed the paperweight dash door stop that they were using here was an interesting shape of rock, and then they actually worked out that it was a meteorite worth many hundreds, if not thousands of pounds, that for years had been kicking around in the office down here. In your adventures in the museum world, did you have any other discoveries like that you're aware of?
Well, not on meteorites, but we did make some really interesting discoveries back in, when would it have been? It would have been about 95. The office we were working on, but bear in mind, Yorkshire Museum was built in 1829 and the office buildings were built about 1845. And they wanted the little staircase which took up to the next level, they wanted to do some repair work on the staircase. So they took away the panels. There was another panel behind that panel. So they took away that panel and they found all these boxes and boxes of old glass plates. You know, the sort of 3-inch square glass plates? You ever seen them before? And they were all wrapped in newspaper and they were all dated, I think it was April 1942, which was when the Baedeker raids hit York. So what someone had done, they'd taken literally, and there were hundreds and hundreds of these. I'd wrapped them in newspaper, put them in boxes, shoved them under the staircase, put a screen up, a wooden, a piece of hardboard or something, or plywood, and it got painted, and then another bit got put on top of that, and it just got forgotten about. So it does happen. And there was loads of astronomical ones there as well. Really interesting.
Excellent. Well, there's still finds to be had in the museums.
Absolutely.
Yeah.
Museums are like iceberg. What you see out front is the tip. Everything is, most of it is actually in store. And loads of things are just boxed up and put into store. And often they won't be looked at for years and years. And then the people who put them there die. And then someone say, what's in that? I don't know. And of course, if there aren't, and often there are not very accurate records, you know, so-and-so donated this in 1863. And it can be fascinating to be digging around there.
Yeah. Do you have your own collection of meteorites that you keep?
No.
No?
No, I'm not quite sure if you've got any meteorite collectors within the Bath Astronomy Society at all, but it's certainly it's something which hopefully I won't be treading on too many people's toes here, but I know there are people who are trying to make meteorites treasure trove because of their importance and their individuality. And certainly I know some people from various European institutions who say that when a meteor hits the ground, particularly in Africa, it should automatically become the property of that country. And I know meteorite people send their people out there and they pay them pennies and they get boxes of stuff and they all get sold on the market. I know it's all absolutely legitimate, but there is a big argument for say it should become the property of that country. And then if they want to sell it, fine, as opposed to what happens today. But I know there is a big campaign within certain elements of the European Space Agency. I know some colleagues of mine who really are advocating to get a UN article published to say they really should become treasure trove in the way when you find a treasure trove in Britain or in Europe, you know, it's gold or it's silver and it's being buried and the person doesn't come back. It is automatically called treasure trove, and that's what they're saying. Meteors should fall into the same category.
Excellent. Any final questions before we close out this evening? No? Well, I'd like to thank you again, Martin, for a wonderful talk to take us through from my favorite dinosaurs all the way through to their slaughter, but then our conquest of the Earth, and yet the impending doom. We shouldn't get too cocky because the next big rock could knock us out. So thanks very much, Martin.
My pleasure. Okay, maybe see you again sometime. Bye-bye now. Bye-bye.
Okay, thanks everyone for coming along. For those that are here in person, is anyone organising a trip to the pub?
Yeah.
Have you selected an establishment you're going to?
The Raven.
The Raven.
Until the Griffin reopens, we'll go to the Raven.
So you're more than welcome. I'm just going to stay back and just clear up inside here. If a couple of people want to help us with the chairs downstairs, that'd be more than appreciated. Just take them down to the bottom of the stairs, just pile them up by the next stairs. Don't need to put them anywhere. That'd be great. And then we'll hope to see you soon. There's quite a few things that are happening in April, but not observing based. But I'm going to try and look at the diary to see if we can get some observing slotted in there as well. Okay, thanks everyone. I'll close down the presentation now and I will see you all soon.
Where would you like the pillows?